Welcome back, Physical Science 20. So I left you with this question here, this example. So again, we're starting with grams, and we need to figure out molecules. So yes, we have to change to moles first of all. And of course, looking at this schematic up here from above, we need to know the molar mass. So the molar mass of C2H4, ethylene. So for every 1 mole of C2H4, we have 2 moles of carbon and 4 moles of hydrogen. Carbon is 12.01. Hydrogen is 1.01. So what do we get here? We got 24.02 plus 4.04, which gives us 28.06 grams per every mole. So starting off with what we're given 7.3 grams of C2H4. And yes, so we're going to go from grams to moles, which means grams on the bottom, moles on top. So we have 28.06 grams of C2H4 represents 1 mole of C2H4. So if we stopped right now, we would be here at moles. But of course, we have to do one more step. 1 mole of C2H4 represents 6.02 times 10 to the 23rd molecules of C2H4. Okay, then we can cancel that off and we'll have molecules. You put that in your calculator, it works out to be 1.566143997 times 10 to the 23 molecules of C2H4. And let's see here, we have 2 sig figs, so that works out to be 1.6 times 10 to the 23 molecules of C2H4. All right, so that's how we do that. All right, one final thing here. If we look at the next page, so we can go, once we have molecules, we can go on and figure out individual atoms that make up that substance. So each molecular compound has a unique chemical formula, which gives the exact number and type of each atom in that individual molecule. Therefore, if the number of molecules is known, chemists can calculate the number of atoms of each element present by looking at what the formula of it is. So for example, the chemical formula H2O tells us that 1 water molecule contains 1 oxygen atom and 2 hydrogen atoms. Okay, because we can see that. We can see there are 2 hydrogens for every 1 oxygen in 1 molecule of water. So there's 1 O atom and 2 H atoms. And then, of course, you can go from there. If you look at the bottom of the page, if I know what, so then I can look at 10, then that would be 10 oxygens and 20. So we know that it's kind of a 1 molecule to 1 atom O to 2 atoms hydrogen. So if I have 10, I'll have 10 and 20. If I have 1,000,000, I have 1,000,000 O's and 2,000,000 H's. And of course, we can describe number of ions in an ionic compound in a similar manner. The difference is that we specify the ratio of ions in a formula unit of a compound. So for example, if I look at aluminum sulfate, we know that there are, for every 1 formula unit, there are 2 aluminum ions for every 3 sulfate ions. So then remember that it's a polyatomic. We're looking at the SO42 negative. So for every 1 aluminum sulfate formula unit, I have 2 aluminum ions and 3 sulfates. So it's a 1 formula unit to 2 ALs to 3 SO4s. So if this had been 100, this would be 200, this would be 300. 1 to 2 to 3 ratio. Or if I'm looking at 1 mole, then it would be 2 moles and 3 moles. Or if I'm looking at 6.02 times 10 to the 23rd, it would be that number doubled, 1.204 times 10 to the 24, or that original number tripled, 1.806. Calculating the number of atoms or ions in the compound follows the same strategy as outlined earlier. Again, the only difference that you have is what the material is we're talking about. So atoms or ions per molecule as in how you would do that. So formula unit deals with ions, whereas molecules deal with atoms. All right, so let's look at an example. Benzaldehyde C6H5CHO is a compound used to give prepared foods an almond flavor. Find the number of carbon, hydrogen, and oxygen atoms in a 26.5 gram sample. So we're going to go from grams to moles. And then this is a molecule. So we're going to go to molecule. Okay, so it's the same thing that we did previously. And then from there, we'll take a look at the extra stuff that we're going to have to do. So regardless, we're going to have to figure out the molar mass of C6H5CHO. So we can see for 1 mole, we have 6 moles of carbon. Let's see, 5 plus, oh sorry, I have 7 atoms of carbon. 7 moles, sorry. And then 5 plus 1 is 6 moles of hydrogen, and then 1 mole of oxygen. So if I look those up on the periodic table, carbon is 12.01, hydrogen is 1.01 of course, and oxygen 16.0. So it's going to give me 84.07 plus 6.06 plus 16. So that is 106.13 grams per mole. All right, so we'll set this up like we did before. So we're starting off with 26 grams. So 26.5 grams of C6H5CHO. And going from grams to moles, yes, the molar mass, grams to moles. Grams to moles. So I want moles on top. And of course I want grams on the bottom. C6H5CHO. So 1 mole is 106.13 Gs. So if I was to stop there, I'd be in the mole area, but of course I want to go to molecules. So that means going over here, going from moles to molecules. Moles on the bottom, molecules on top. Molecule C6H5CHO. And of course 1 mole is 6.02 times 10 to the 23rd. Okay, so what I'm going to do is I'm going to calculate what that is. So calculate what that is. That's going to give me, with your calculator, 1.503156. I'm not going to round off yet. I just want to have that number down. Molecules of C6H5CHO. All right, so here I am. I know molecules of that, but I want to figure out individual carbon, hydrogen, and oxygen atoms. And to do that, we use the formula. So here we could say, use formula. And of course the formula is C6H5CHO. So with that, I'm just going to add this in here. You can write this on your blue sheet too, but to find the atoms, use the formula. Okay. So carbon, hydrogen, oxygen. So maybe we'll just go over here and say carbon, hydrogen, oxygen. Okay, so start from here. This is where I left off. So 1.503156. And again, don't round off. Molecules of C6H5CHO. And for every one of these, for every one molecule of C6H5CHO, you can see that there are, let's see, 6 plus 1, 7 atoms of C. So I get 7 times. For every one molecule, I get 7 times the carbon. So that's what I mean by using the formula over here to figure out the individual atom, figure out how many carbon atoms are in one molecule, or whichever one I'm talking about. So when I do that, I get 1.052209 times 10 to the 23 atoms of C. And my original question had, let's see, my original question was 26.5. So that is 3 sig figs. So I need to have 3 sig, let's see, 1, 2, 3. So 1, 2, 3, so that's going to give me 1.05 times 10 to the 23 atoms of C. There we go. So I'm going to get you to see if you can do the last two here, the hydrogen and the oxygen, using the formula of C6H5CHO. So do that, see what you get for an answer there, and then we'll talk again. All right, see you again.